This is page 40, number 3C. We're trying to find the surface area of a cylinder on top of a cylinder. This is the entire question. It doesn't say anything about this being a real object in the real world, so we'll assume that the bottom counts. So we're assuming that surface area counts. Having said that, this little circle here is part of this big circle here, so I don't really need to calculate it. If I calculate this big circle and the bottom one, that includes this one. And then you don't have to worry about the fact that this one actually makes a hole. So I only need, for surface area, 2 pi r squared. Now, sometimes when I'm doing a problem like this, I'll break this down this way. I'll say that radius 1 is the big radius, so that'd be my half of 10. And radius 2 is my small radius, which is half of 2, which is 1. And then I'll go into my formula and make sure I remember which one I want. So there's the formula for these two circles right there. Next, I need to worry about the curved surface. This one around here, and that's a 2 pi r h, but again, that's my big radius. After that, all I need is this one. And that's another 2 pi r h, but this time I want the small radius because it's that line there. So, putting it all together and plugging numbers in, 2 pi r squared is 2 pi, and again, I want radius 1, so that's 5 squared. The green part is 2 pi 5, and the height of this prism, or cylinder, is 2. And then it's 2 pi. Radius 2 is half of 2, which is 1. And my height here is 10. Anytime I get a question like this that gives me nice, easy numbers to work with, I like to do as much algebra as I can. This might be the question I had a second ago from somebody in the class. Do we have to do algebra for these? Technically, here in grade 9, if you just ran this mess through your calculator, you got the right answer, you can move on with life. But at the pre-calculus level, they're going to want you to actually work with this stuff in the following way. So those of you who sign up for pre-cal next year, be prepared to be able to do what I'm about to do here. I know 2 times 5 squared is 2 times 25. So that's 50 times pi. Plus, this part here is 2 times 5 times 2. 2 times 5 times 2 is 20. So that's 20 times pi. And this part here is 2 times 1 times 10, which is also 20 times pi. Now I can kind of treat these like pieces of algebra, like they're all like terms. So that's 50 pi plus 20 pi plus 20 pi is 90 pi. And again, at the grade 10 level, they'd probably just say, leave it like that, 90 pi centimeters squared. Unless, of course, it's an applied math problem, in which case, you know, say you wanted to know exactly how much surface area this had because you wanted to paint it or cover it with wallpaper or something. And you're not going to go to the store and say, please sell me 90 pi centimeters squared of wallpaper. So we need a decimal from here. And if we're going to punch buttons, we get, and that gives you 282.7 centimeters squared. I think the textbook actually rounds it to 283. So good enough. Please notice that this is the same decimal I'd have got if I'd have just punched this whole thing through my calculator here. But this is a nice, easy way to get there if you have a little bit of algebra skill.